Number 18, a chain of car muffler and brake repair shops maintains a training program for its mechanics. All new mechanics begin training in muffler repairs. Every 3 months, the performance of each mechanic is reviewed. Past records indicate that after each quarterly review, 30% go from of the muffler repair trainees are promoted to brake repair. So that's a 0.3. 20% are terminated for unsatisfactory performance, and the remainder continue as muffler repair. So we have 30, and then 20 are fired. So then we have 0.5 and 20 that are terminated. Okay? So that's all added up to 1. Next, 30% of the brake repair trainees are promoted to full-time mechanics. So they go here. They require no more training. So they are at 0.3. And 10% are terminated for unsatisfactory performance. So that's 0.1. And the remainder continue as brake repair trainees. So if we have 0.3 and 0.1, that's a total of 0.4, which means 60% stay in brake. Now, if you're terminated, you don't go anywhere because you're terminated. So we're just going to put a 1 there. And if you're a full-time worker who needs no more training, well, you're not going to be a muffler trainee or a brake trainee or be terminated, unless there's some mysterious circumstances. So that's also going to be a 1 there. So we can translate this into this matrix down here. All right, but I went ahead and put this into standard form because, as you can see, terminated and full-time, they are absorbing states. Right? They don't go anywhere except for into themselves. So I went ahead and made that into a standard form. So with our I, our 0 matrix, our R, and our Q, I can go ahead and put this into a limiting matrix. So what I'm going to do is take F and do an identity minus our Q, which we already have our Q here. Our identity has to be the same size as our Q, so it's a 2 by 2. And then we get a 0.4, a 0, a negative 0.3, and a 0.5, and we want the inverse of that. Now you can go ahead and figure that up if you want. This is it. And then multiply that by our R, which is given right here. Or you can just put this in your matrix, in your calculator, do an inverse, and then multiply it by the R that way. It's up to you. Either way, we're going to need this information for later, so you're going to do both. So once we do this and we plug this in and we find our F times our R, we're going to end up with a 0.25, a 0.75, a 0.55, and a 0.45. And so that just goes right here for our limiting matrix. And 0.55, 0.45. So now we have what we need to answer the questions, right? Part A says, in the long run, what percentage of muffler repair trainees will become full mechanics? Well, we have muffler repair trainees to full mechanics. That's a 0.45. Part B, it says, in the long run, what percentage of brake repair trainees will be terminated? Well, we have brake repair trainees to terminated, 0.25. Now for part C, it says, what is the average number of quarters that a muffler repair trainee will remain in the training program before being either terminated or promoted to full mechanic? So what we do for that is we just look at our F. That's it. We're looking at our F. And we know we have brake repair trainees and muffler repair trainees. Well, it's specifically asking about the number of quarters that a muffler repair trainee will remain in the training program before they're terminated or promoted to full-time. Well, that would be this and this. So all we have to do is add those two together. So 1.5 plus 2 is just 3.5. So 3.5 quarters is how long it will take. And that's it.